Okay, fine. So let's consider what is osmotic shock. Osmotic shock is, let's apply this concept to the biological fluids, which means I mean to say there is a beaker and we have taken water in this beaker and we add cell. Now, of course, size of cell is very small as compared to the beaker. For a single cell, beaker is acting like ocean, right? Okay, so it is very small. Now, as I told you that this cell wall will act as a semi-permeable membrane, right? Okay, cell have cytoplasm. In cytoplasm, there are salts dissolved. Okay, and this water, I forgot to mention, this water is distilled water. Okay, distilled water. So obviously there is no salt concentration outside and inside there is a salt concentration. The similar thing that diagram 1, if you remember that. Okay, what is going to happen? Salt cannot go outside of cell to maintain the equilibrium, right? Okay, so what, because cell wall will not allow salts to go out. Okay, so what will happen? Water will enter this cell. And what is the fate of this cell? What is happening to this cell? The cell will increase in a size, okay, because water is moving inside to dilute the concentration to maintain the equilibrium, and cell will bulge, and at some point this bulged cell will burst. Okay, okay, so this cell will burst and cell will die. Okay, okay, so this cell is getting dead because of osmotic pressure, so called, that the process of osmosis. This thing, okay, this process is called as osmotic shock. The cell has got osmotic shock and it got dead. Okay, so now what is the application? Now let's consider reverse of it. Okay, consider reverse condition of it, which means for example there is a beaker. Okay, consider this beaker, there is a water in it, we add a cell, but here condition is different. We are adding NaCl in a beaker. Now very high concentration of NaCl outside, okay, and very low concentration of NaCl inside. Okay, this is cell, this is semi-permeable membrane, cell wall, okay, or cell wall. Okay, so what will happen to this cell now? Obviously cell cannot lose salts, but it can lose water, because water is solvent. Semi-permeable membrane will allow solvent to go out. Okay, so solvent will go out to dilute outside concentration to maintain the equilibrium. And what will happen to the cell? Cell will shrink because now water is lost. Okay, so this cell will experience dehydration. Okay, because there is a outgoing of water. Okay, this dehydration may be permanent or may be temporary. If cell wall is elastic, if you restore the concentration which is equal to the cell cytoplasm, what will happen? This water, excessive water which has gone out, will again re-enter the cell and cell will gain its original position. So in this condition, cell may not die. It will just shrink its size. Sometimes if cell wall is thick and non-elastic, what will happen? It will change its shape permanently and cell will die out of dehydration effect. Okay, or maybe because of change of its size. Okay, that may cause change in the pore size and all, and that may cause death of the cell sometimes. But most of the time cell will regain its original position and will live again, right? So this is called as osmotic shocks. This process is called as osmotic shock. The pressure of unit of osmotic pressure is same as that of pressure, right? Let's move to the next part very quickly. Okay, so what are the application of osmotic shock or osmosis? Okay, it is used for preservation of fruits and vegetables. So you put your vegetable or fruit in a salt, what will happen? Microorganism will not attack that fruit or salt, because microorganism has to enter that salt condition or salty solution where it will cause dehydration and cell death. So if there is a cell death, there is a no microorganism, there is a no microorganism, there is a no decomposition. So your fruits and vegetables are being preserved. Used in a sterilization, as I told you in a previous diagram, that cell is getting dead because of osmotic shock. Suppose you want to sterilize any solution, you know that there are bacteria, so you can create osmotic shock in that solution and cause death of the cells, which is causing sterility. Okay, it is used in a sterilization process. Now in a parenteral and saline, the same way, where sterilization means what, you are using this mechanism to kill the cells. So the same way, uh, it may be harmful to us also, like when if you are injecting any solution in the veins, directly into the bloodstream in a parenteral route, what will happen? If you are injecting distilled water, what will happen? It will cause osmotic shock to the nearer cells. Cells may get dead, and if the organ is sensitive, it will start irritating that area. Okay, so of course we are not supposed to punch distilled water in a blood. Okay, that will cause osmotic shock. So what we are doing, we are actually using water for injection, or we can say saline also being used. What is saline? It is 0.9% weight by volume NaCl. Okay, so NaCl concentration 0.9% weight by volume. Okay, so it is equivalent to your blood salt concentrations. Okay, so it will not cause any osmotic shock after punching of injection. Now seawater versus distilled water. Many times competitive exams ask this question. Okay, about they give four concentrations, and which is the most harmful concentration? Okay, or which concentration is most irritating to your eyes? So answer is distilled water, because your tears or eyes do have water and that have salt. You might have tasted tears, and they are salty, right? So distilled water, when you're adding distilled water in the eyes, they will start irritating, because it will give osmotic shock to the eye cells, and cell may get dead if the shock is severe, and that causes irritation to the eyes. Okay, but seawater, comparatively less irritation will happen, because salt concentration is not hugely different, but it is a little bit different. It will get managed, right, or balanced by the body. Same way, you cannot drink distilled water, because if you are drinking distilled water, it is causing osmotic shock at the local cells of the stomach or intestine, and that cell may get damaged, and your stomach may start hurting badly. So distilled water is not good for health. Okay, so come to the reverse osmosis. As I told you, remember the diagram, that where there is an imbalance of water level. Okay, so what is happening in the reverse osmosis? The RO unit that you are using for purification of water, what they do is that they apply semi-permeable membrane. Okay, there is a chamber 1, there is a chamber 2. Okay, tap water is coming to chamber 1, and it is getting passed through semi-permeable membrane to the chamber 2. Okay, so it is getting stored there, and there is a difference between between the uh, levels of water because of salt concentration. So what will happen? We are creating a pressure so that only water will pass through semi-permeable membrane, and ions like NaCl and minerals and other like fluorides. There are many particles uh, in a TDS. Okay, so these particles are getting blocked by semi-permeable membrane, and only purified water is going through unit B. So this whole process is called as reverse osmosis. Okay, it is also used by plants to transport water, just like at the start I give an example, coconut tree. So it will take the water from the ground, and using capillary effect as well as osmosis, that water will reach to the top in the coconut, and it is getting stored over there. So it's a miracle. It's a logic behind that. uh, the process is called as osmosis. Okay, in the next video we will see what is the unit of osmosis or osmotic pressure, and what are the laws that are governing osmotic pressure. Okay, and other details. So stay tuned for next episode. Thank you.